Hello and greetings to you. Once again, welcome to my channel. In today's video, we are going to look at cells and operations on cells. To look at cells and operations on cells, first of all, we need to know the meaning of sets, or what a set is. And we said that a set can be defined as a collection of objects which are of the same kind. And the objects within this set or the set are called elements or members of the set. In representing sets, we use capital letters. And some examples are, we can have a set of students in a class. We can also have a set of counting numbers less than 10. Another example is a set of all Ghanaians living abroad. We can also have a set which is labeled as gene with elements 1, 2, 3, 4, 5, 6, and 7. Then we can have another set H, which is labeled as or with elements A, B, C, and D. So when you look at set gene and H, you see that we have capital letters there. So that is why we said sets are represented by capital letters. So these are just some examples of sets. You can mention a lot of examples, but these are just a few. After we knowing what a set is and examples of sets, let's now look at how to describe sets. So in describing sets, we will be concentrating on 3 ways by which we can describe sets. The first example is by using words to describe sets, or we say by word description of the elements, or by defining the property of the set. For example, if we have set A equal to odd numbers less than 10, or we can also have a set B which is containing counting numbers. They are described by words. Then we can also have set C, which is a set of prime numbers less than 12. Another way we can describe sets is by listing the elements of the set. And by listing the elements of the set, we are now going to use the properties to list the elements of the set. For example, set A was odd numbers less than 10. And we all know that odd numbers are numbers which are not divisible by 2 exactly. So when we are going to list the members or the elements of set A, we'll have set A to be 1, 3, 5, 7, and then 9. You see that the last element here is 9, and when you compare, it is less than 10. Then for set B, that we have a set of counting numbers. Counting numbers are numbers starting from 1 to infinity. So listing the elements of B, we have set B to be 1, 2, 3, 4, 5, and it continues indefinitely. Because here they said counting numbers, it has no range, so this continues indefinitely. We can also have set C to be 2, 3, 5, 7, 11, because it said C is a set of prime numbers less than 12. So the last element here is 11, which is less than 12. And we say that prime numbers are numbers with only 2 factors, that is 1 and the number itself. So these are described by words, and this by listing the elements of the sets. The third way by which we can describe sets is by using the set builder notation. And the set builder notation, we are going to consider the beginning and the ending of these sets. Also, make good use of the signs less than and less than or equal to. For example, set A is x is set that 1 is less than or equal to x, which is less than 10, where x is an odd number. The elements of set A started with 1 and it ended with 9. So this becomes the set builder notation for the set. Then for set B, it began with 1 and it continued indefinitely. So have 1 is less than or equal to x, where x is a counting number. Then for set C, we'll have x is set that 1 is less than x, which is less than 12, where x is a prime number. Then we are now going to look at kinds of sets, and we are starting that with finite set. A finite set is a set whose elements can be counted, and in this, the counting process comes to an end. That is, the last element of this particular set is known. For example, if we have set W, which is equal to 1, 3, 5, 7, 9, so that the last element of W is 9. So it is an example of a finite set. We can also have a set starting from 2, 3, 4, 5, 6, and it continues to 1000. The last element is 1000. So it is also a finite set. It has an end. Then we can also have a set of students in a class, because the number of students in a class can be known. So this also becomes a finite set. There are a lot of examples of finite sets you can relate to. We are going to look at also infinite set as a kind of set. An infinite set is a set whose elements cannot be counted. That is, the counting process does not end. So infinite set is the opposite of finite set. So in an infinite set, the last element of that particular set is not known. For example, we have a set of counting numbers. A set of counting numbers. There's no range. For that matter, it has no end. Then this is set starting with 2, 4, 6, 8. We can say that this is a set of even numbers starting from 2, 4, 6, 8, and it continues indefinitely. This shows that. So this indicates it has no end, which makes it an infinite set. There are a lot of examples, but these are just few. Then another kind of set we'll talk about will be the empty set or the null set, which is a set without an element or a member. And a null set is represented by the symbol this. So when you see curly brackets without an element between them, it represents a null set. Or you see this particular symbol that also represents a null set. We can also have a unit set which has only one member or element. And examples are, we'll have set X, which is equal to 0 as an element, set Y having 4 as an element, and set Z having 9 as an element. These are examples of unit sets because they have only one element in them. Let's now look at the relationship between sets. I'll start with the equal sets. For equal sets, two or more sets should have exactly the same members or elements. For example, a set A is equal to 5, 7, 9. And set B is equal to 9, 5, 7. See that set A and set B have the same elements, but their arrangements differ. So this makes them equal sets. Then we also have equivalent sets. For equivalent sets, two or more sets are said to be equivalent if they have the same number of elements. Example, if you have set P equal to 2, 3, 4, 5 and set Q equal to A, B, C, D, see that this has 1, 2, 3, 4 elements. This also has 1, 2, 3, 4 elements. So this makes them equivalent sets. So when you look at the difference between equal sets and equivalent sets, equal sets, the elements must be the same. But in equivalent sets, the number of elements must be the same. Then we also have the universal set, which contains elements under discussion. It contains all the elements under a particular discussion, and usually we use the letter U to represent universal set, or you see xi, this Greek alphabet, which is called the xi. We use the xi to represent the universal set. We also have the subsets. When we consider two sets, let's say set A and set B. Set A is a subset of set B and is denoted by A, this, and B. If every element of set A is an element of set B, that is, if all the members of set A can be found in set B, then we say that set A is a subset of set B. For example, if set A is 3, 4, 5 and set B is 3, 4, 5, 6, and 7, we can see that 3 can be found in B, 4 can be found in B, 5 can be found in B. That means all the elements of A can be found in B. So this makes set A a subset of set B. Generally, the number of subsets of a given set can be determined using two exponents, n, where n is the number of elements, or we'll say the cardinality of the set. Example, if we have set A equal to 1, 2, 3, the cardinality will be 3 since we have 3 elements or 3 members. And the number of subsets will be 2 exponent 3, which is equal to 8. We can now list the elements or the subsets starting with the null set. So have the null set 1, 2, 3, 1, 2, 1, 3. Then we also have 2, 3. We have 1, 2, 3. The set itself. So we have 1, 2, 3, 4, 5, 6, 7, 8 subsets. We have to take note that the null set and the set itself are also part of the subsets when you are listing them. So also, considering set H, which has elements A, B, C, D, the cardinality will be 4 since we have 4 elements in that particular set. So we can find the number of subsets by raising to exponent 4, which will be 16. That means set H will have 16 subsets. And the list of the subsets are here. We have the null set A, B, C, a set containing D, A, B, A, C, A, D, B, C. Since we have 4 elements, each element is a subset of the set. Then when you combine any two, you will get a subset. When you combine any 3, you get a subset. So combine to have AB, have AC, we have AD, which is here. Then we also have BC, we can have BD, we can also have CD. Then we have any 3, so have ABC, we have ABD, we have BCD, ACD, and the set itself. So this becomes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 subsets. So this is how we find the number of subsets and the cardinality, and also list the subsets of any given set. Let's try finding the cardinality, the number of subsets, and by listing the subsets of set B, which is equal to 2, 4, 6, 8, 10. Thank you very much for watching. Please subscribe, comment, and share. Then take notes for the next video. Thank you very much for watching. And we shall review this particular example in our next video. Thank you and bye for now.